I love engineering. It's the only field where you can basically build everything. Buildings, cars, bridges, iPods, phones, computers, planes, buildings that control bombs, cars that carry bombs, bridges that act as routes for bombs, planes that drop bombs, planes that are bombs.
As we see again this extraordinary shot of the second plane hitting the tower.
I was kind of thinking of the Japan one. Yeah, that's more like it. Bomber planes are such a terrifying yet intriguing part of engineering. The science needed to essentially develop a piece of technology that can wipe out a city block, or as what certain nuclear bombings have taught us in 1945, entire cities. It's both intriguing as it is terrifying. It's ironic considering how many are usually taught to use their abilities for the good of mankind and to help bring peace, yet I guess the definition of peace sometimes is a six-figure salary contract at Northrop Grumman to develop bomber planes like this beast. Of course, now that I said that, I can imagine they're already plotting to strike me literally, so let's just try to make this quick. First off, what even is this thing? Well, this is a bomber plane, but more specifically a stealth bomber.
These planes are different from normal bombers, as bombers tend to be a broader category of planes designed to utilize torpedoes, bombs, and other air-to-ground weaponry to attack targets.
However, stealth bombers do their job in such a way to the average person, and especially to enemy military powers, that they rarely can ever see it coming. A literal surprise strike that is sure to crumple any country to dust, or, in the case of the B-2 bomber, basically any Arab country. You might be looking at this plane and understandably go, how is a plane that just looks like a hybrid Dorito any more stealthy? Well, that's actually the unique part. It's actually surprisingly genius, despite it really looking just like a flying Dorito. But first, a quick history lesson as to how a plane like this even came about, and trust me, there is a lot of physics to be seen here. Long ago, in the 1940s, an American engineer by the name of Jack Northrop was at the peak of his obsession with one incredibly niche thing: airplane wings. He shared the firm belief that only having the wings of a plane and getting rid of other parts like the fuselage or anything made to generate lift, which is the physical force that pushes an object, like an airplane wing, upwards to the sky, that you could make the most fuel-efficient plane ever made. It was ambitious for its time, given the limited progress in science and physics, but time itself would prove it shockingly possible with an unforeseen advantage. In 1962, a Soviet physicist named Pyotr Opstev, I don't know how to pronounce that name, published a scientific paper, and the Soviet Union deemed it fit for international publication because it didn't see any military advantage in its findings. Engineers at Lockheed, now Lockheed Martin, would come across the paper to learn something that the Soviets didn't know: the superpower that only physics could make possible. The Soviet scientist had unintentionally discovered the ability to be invisible to aerial radars, a real-life cloak of invisibility. The research paper in question had made the conclusion that electromagnetic waves scatter on smooth surfaces. That's literally it. But it was enough to develop the first stealth plane concept, known as the Hopeless Diamond, which unironically looks more like a Dorito than the B-2 bomber. I kind of wonder if it would be crunchy. This concept would later develop into the Have Blue, a proof of concept of a plane that could deflect radar and infrared detectors and essentially go invisible. Many decades later, they understood that if they wanted to create something truly made of stealth, they would want to have the plane essentially reflect the infrared like a mirror. Decades of developments in math, science, military spending, and most importantly, supercomputer technology, and now the B-2 bomber is born. Lockheed Martin and Northrop Grumman were able to outdo themselves with the development of one of their most advanced bombers yet. So now let's see what, with the power of physics and science, the peacemaking engineers were able to make. The B-2 bomber's boomerang shaped, as we covered earlier, really helps with its efficiency. The lack of a fuselage and unique design create lift on the entire plane, rather than only relying on the wings of the fuselage, as with both previous bombers and with planes in general. Its high efficiency does create more drag, which is essentially the resistance of force acting on the plane. Despite how advanced the entire plane is, it's surprising to note that it's only high subsonic. It's not the fastest, but its speed puts it at literally just underneath the speed of sound. Traveling at around 305 meters per second or 1,000 feet per second, its high efficiency can allow it to travel 6,900 miles or 11,000 kilometers without ever refueling, or even longer at 11,500 miles or 18,500 kilometers if they just do one in-flight fueling. For comparison on just how wild this number is, the United States itself from coast to coast is 2,800 miles or 4,506 kilometers. If you do the math, this plane can travel from New York to California roughly 4 times off of one full tank without ever refueling. That, combined with its speed, would make it so fast it could possibly make its way there in minutes. I wouldn't know because I'm a little bit too lazy to do the math on that, but you get exactly what I mean. The point is, this thing can go for miles and can go fast. Now, for the whole point and the main focus, the stealth. How is this giant boomerang Dorito mashup somehow one of the most stealthiest bombers in the world? Well, of course, from the very beginning, these planes were designed with stealth and a low profile in mind. The slim, black design is designed so that, while flying, it is invisible at night. Even during broad daylight, it can be difficult to identify where it might be heading. Its flat design is purposefully made to make the bomber sleek and out of sight, with an exterior designed around the workings of radar and sensor technology, thanks to the research mentioned earlier. Because of this, the only time people would even know this bomber plane had arrived would be after it had already struck, and by then it would be too little too late. It's hard to tell where exactly the bomber is going. I mean, for crying out loud, the surface of the bomber plane absorbs radar. Just remember, radar is essentially electromagnetic waves, working similarly to the way light works. The black color might be good at absorbing light rays, but the material itself and the way it is formatted absorbs the electromagnetic waves. The key here is making this plane almost invisible to absorbing everything from a physics standpoint. It absorbs light rays with a black finish and absorbs electromagnetic waves to be completely invisible to radars, to the point where even the tape on the plane is designed to absorb the energy. On an interesting note, not a single part of the plane has a rough edge. Because of the smooth surface, it makes it easier to absorb and get rid of electromagnetic waves. The only way a radar can detect something is if the wave bounces off the plane. So, with the plane absorbing it, the radar quite literally sees nothing. Even sound is absorbed within the bomber plane. In case you didn't already know by now, jet engines and the components that make them can get really loud, especially for fighter jets. So, with something designed to be invisible, how do you make it more quiet? Well, you can do that by putting it inside the plane itself, as well as other components like the landing gear and the bombs themselves. It should be noted that the plane itself does in fact have a built-in radar system, as well as other technologies that either require or use radar. The only difference is that, unlike most radars, where it's a lot more scattered and broad, the radio wave technology used by the B-2 bomber is a lot more focused and smaller. This allows it to communicate with ground control and other planes flawlessly while not jeopardizing getting caught. Already, we've seen them manipulate and absorb radio frequencies to be invisible to radars, absorb most of the sound waves produced by putting their noisiest components inside the plane, and even the curvy shape of the plane is designed to reflect waves like a mirror. In fact, allow me to quickly further explain that. Notice how when you look at a mirror, you see, well, yourself. But from looking straight at the mirror, you see a complete reflection of yourself. What if we, I don't know, looked at it from a different angle? Suddenly, you're now not only seeing yourself, or maybe not even seeing yourself at all, but probably just the wall or the area next to it. Because of the way that light works, it bounces in a way that doesn't directly showcase the object in front of it. This is exactly what the B-2 bomber does with the few parts of the plane that are actually reflective in a way. By leaving it in a curvy shape, no electromagnetic wave or light ray, for that matter, can ever make a direct reflection, leading it to essentially and literally go dark. Finally, we need to talk about the weapons themselves, the bombs. It's funny to hear that it was originally going to hold nukes during the Cold War, and after the fall of the USSR, they repurposed it into what is now known as a multi-role bomber. It basically carries conventional bombs and nuclear munitions. Great, that's just great. So now they can bomb both a city block and half a country. They have rotary launchers in the bomber that essentially allow computers to send a signal to deploy the exact bomb needed, essentially rotating and mechanically prepping the bomb to be dropped. The plane is armed with dumb gravity bombs alongside other, more precision and smart bombs designed to specifically attack targets. Overall, the B-2 bomber is simply one of the most advanced and most dangerous pieces of aviation technology probably ever made. Its ability to be invisible to both civilians and enemies makes it a formidable threat, and one that under the wrong people can create mass amounts of destruction. One moment you're sitting down minding your own business, then bam, it's all over.
All of that just to bomb Afghanistan? Guess they can't handle every brown guy. It can be both impressive and terrifying. Not only just in terms of bomber plane technology, but also in terms of military technology as well. Like, you mean to tell me the same company behind my washing machine also makes bombs? Oh no, wait. Give me a second. Yeah, let's see what's going on here. Let's see. What's going? Oh. I guess when they struck me down, they decided to put a M instead of a B and hit the wrong place. Probably the first time I've ever been happy that somebody got my name wrong. I'm getting kind of hungry. Y'all want Oreos?